In this final video for the demo section, I would like to talk about some of the finer details of the evolutionary simulator. This is because in any evolutionary process, the characteristics of the evolutionary process itself will have a big impact, of course, on the final outcome of the entities involved. In the evolution simulator, we can go to the defined tab to see the default values that are used to direct the evolutionary process in the simulator. So we have detrimental cells are -1, neutral cells are 0, positive cells are 100. And each one of these values will have an influence. So these can be changed as one wishes, and they will have an influence on the evolutionary process itself. For example, by increasing the detrimental value to, say, -10, we would expect that cells are far less likely to move into that territory because the punishment has been increased. As in a similar way, for positive cells, there is 100 units of energy available for in each cell for each species. So by increasing this number, we allow the possibility of more cells, more species in each cell. The two values below that, the mutation rate and the cell penalty, will also have a direct impact on the evolution of your simulation. So the mutation rate is the chance of a mutation occurring. So for each cycle, each individual is replaced, and for each cycle there is a chance, the chance of that mutation occurring is whatever has been set here. So 5 and 100 is the default value, and you can decrease or increase that as long as it's between 0 and 100, and that will give you the different results based depending on how you set that. Now, cell penalty will also directly influence the evolution because every cell demands penalty. So because energy is used just to sustain a species, the cell penalty represents that use of energy, and by increasing that value, then we will see basically more cells being less likely to use neutral cells, as they have been penalised for using those neutral cells. Now, a quick word on the actual process itself, the actual mutations that occur when simulation is in progress. So when a simulation starts, there is a chance of mutation occurring, and there are 6 possible mutations that can occur. There is a different direction. So for example, this cell has expanded into the right hand side, and has done that by adding a gene. So that's also another difference that can occur. We can have the addition of a gene, the splitting of a genome, or a change in any one of the genes. So for this new species to occur, we can see that an additional gene has been added to the original species, and that direction of that new gene has been randomly selected, and it has ended up being right, and so that new species has added the location of the parent species plus 1 cell to the right. Now, in deciding what processes are possible, the coding has used nature as an example. So we know from natural evolution that when we look at the DNA of animals, there is the chance of additional genes being added. There's the chance of splitting of the genome, and there's always a chance of particular genes being changed or replaced. So that has been used as a guide for the algorithm that the code in the simulator uses. However, one noticeable difference between natural evolution and the simulator is the probability that these different types of mutations will occur. So in the simulator there is currently a relatively equal chance of any one of those mutations occurring. So there's 6 possible choices, and 4 of those are going to be a change in the direction of the genome, and then there's going to be a 1 in 6 chance that the genome has been split, and there's going to be a 1 in 6 chance that a gene is added to the genome. So of course this doesn't mimic natural selection, but then the simulator isn't mimicking natural evolution anyway, because of course we are dealing with a 10 by 10 table on a desktop, while natural evolution is dealing with hundreds of millions of genes that allow for many times magnitude of complexity than what we'll ever see in the simulator. So I'll leave the video there, and hopefully there will be enough information for you to be confident in running a simulation. Now I will include more detailed information on about section which is yet to be added, and feel free to send any questions to me via the contact page. Thanks for watching.